Hello my dear students, in this lecture we are going to see one numerical on radiation topic, that is radiation heat transfer between two bodies. Let us understand the question. The question is, the filament of a 75-watt light bulb may be considered as black body radiating into a black enclosure at 70 degrees Celsius. Now here, let us say we have one bulb. Let us say this is a bulb, right? This is how the bulb is shown. Here there will be a connection, right, for the bulb, and there is a filament. This is a filament of this bulb, right? Now my dear students, this filament of this bulb, let us say this is the filament of this bulb, right, and the heat, it is a 75-watt bulb, therefore heat in this bulb, the heat will be 75 watt, right? Then the let us say this filament is considered as body 1. I am considering this filament as body 1, right? And this enclosure, this complete space, I am considering as body 2, right? There is a radiation heat transfer between this filament and this enclosure, right? Here one is filament, and 2 is enclosure of this filament, right? Then this enclosure is at temperature 70 degrees Celsius. Therefore, T2 is given. T2 is equal to 70 degrees Celsius, which is nothing but 70 plus 273 in Kelvin. If I want to convert into Kelvin, therefore this T2 will be equal to 343 Kelvin in Kelvin, right? Then again, both are black bodies. As both are black bodies, therefore emissivity of 1 is equal to emissivity of 2 is equal to 1. For black body, emissivity is equal to 1, right? The filament diameter is 0.1 mm and the length is 5 centimeter. Now for this filament, the diameter is, let us say, D1 is equal to 0.1 mm and length L1 is equal to 5 centimeter. Then considering only radiation, determine the filament temperature. Now considering only radiation, determine filament temperature. Now my dear students, what will be the area of filament? It is a wire. Let us say the wire is like this. Therefore, the area of filament in contact with this enclosure 2 is this surface area of wire as well as this cross section area of wire on both sides. On both sides, this cross section is also in contact as well as this surface is in contact. Therefore, area of filament in contact with the enclosure is nothing but here pi dl plus 2 times pi by 4 d square, right? This area we have to consider, right? And my dear students, the radiation heat transfer between any two surface q1 to 2 is nothing but sigma T1 power 4 minus T2 power 4 divided by 1 minus emissivity 1 divided by area 1 emissivity 1 plus 1 here 1 divided by plus 1 divided by here A1 F1 to 2 plus 1 minus emissivity 2 area 2 emissivity 2. This is a formula to find radiation heat transfer between any two surfaces, right? Here both are black bodies, therefore emissivities are 1, therefore 1 minus 1 is 0. Therefore for here this term will cancel, this term will cancel. Therefore what will be the resulting equation? Q1 to 2 will be equal to, now this A1 F1 to 2 will go up, therefore A1 F1 to 2 sigma T1 power 4 minus T2 power 4, right? This will be the resulting equation. So let us solve this resulting equation. Now my dear students, here area, how to find area we have seen for this filament, right? Pi dl, because here this, for this filament, here diameter, both side diameter as well as this surface area is in contact with this enclosure, therefore complete area we have to consider, right? Now F1 to 2 for this filament, for such a type of surface, this is a 1, right? This filament is a 1. For such type of surfaces, the safe factor of this surface with respect to itself, that is F11, is always equal to 0, right? So my dear students, we can say F11 plus F1 to 2 is equal to 1. This is the addition of all safe factors is equal to 1. Therefore we can say F1 to 2 is equal to 1, right? Therefore here F1 to 2 is 1. Area is pi dl plus 2 pi by 4 d square. Sigma is here Stephen Boltzmann's constant 5.67 into 10 to the power minus 8 watt per meter square Kelvin, and temperatures are given. Now here Q is given 75 watt. Here we have to find temperature of filament, that is T1. T1 is a question, right? So let us solve this question. Now my dear students, here I am going to erase this question so that we will get sufficient space, right? So let us solve here. So the resulting equation, the final resulting equation we got, Q heat transfer is equal to Q is equal to A1 F1 to 2 sigma T1 power 4 minus T2 power 4. Let us put the values. Q is 75 watt. Area 1 is, let us put pi dl plus 2 into pi by 4 d square, right, into EF 1 to 2 is 1 into sigma is 5.67 into 10 to the power minus 8 into temperature power 1, temperature 1 power 4, right, minus T2 is 343 power 4, right. So let us put the values. Now let us put the values of diameters, right, and length. Now my dear students, here we can write, simplify this equation. 75 is equal to pi into diameter is 0.1 mm, convert into meter, therefore 0.1 into 10 to the power minus 3 meter, into length is 5 centimeter, convert into meter, therefore we have to multiply with 10 to the power minus 2, therefore 5 into 10 to the power minus 2, it is meter, plus here area, for this area, plus 2 into pi by 4 diameter square, diameter is 0.1 into 10 to the power minus 3 whole square, right, this will be the area, into 5.67 into 10 to the power minus 8 into T1 power 4 minus 343 power 4, right, 343 power 4. Now my dear students, this is a school level mathematics. Now here only T1 is unknown, so let us solve this equation for T1, because here only T1 is unknown. Let us solve for T1, and if I solve for T1, I think T1 will be equal to 3028.64 Kelvin. As here T2 we have kept in Kelvin, the answer will be in Kelvin. Therefore in degree Celsius, T1 will be equal to 3028.64 minus 273 degree Celsius. It will be degree Celsius, right? Therefore in degree Celsius it is 2755.64 degree Celsius. This will be your answer. Thank you dear students. In next lecture we will see one more numerical on this topic which was asked in previous year GATE examination.